The topic of this video is graphing transformation techniques, vertical and horizontal reflections. Consider the graph of f of x below, shown here. Use the graph of f to create the graph p of x, which is equal to f of negative x. Okay, so once again, we are provided with a graph, and we are told that this graph is f of x, our parent function. It's almost like another basic function that we never learned about, or another library function that we never learned about. It's being given to us in this problem. So our job is to figure out how do we take the graph of f of x, shown here, and turn it into the graph of f of negative x. So the first thing we should do, since we have been given this graph, is to come up with the coordinates. We are very much accustomed to our library or basic functions being not only a picture, but a table of x's and y's as well. So let's go ahead and use this table here to create that collection of x's and y's. So we have this point, which is negative 2 pi, comma 0. We have this point, which is negative pi, comma negative 6. We have this point, which is the origin, 0, 0. We have this point, which is pi, comma 6. And we have this point, which is 2 pi, comma 0. These are the coordinates we associate with f of x. So what would the coordinates of f of negative x be? Well, we ask ourselves the same two important questions we've asked so many times before, which is what changed and where? Well, what changed is this negative, and where it's located is inside close to x. So when your change is inside close to x, that is indicative of a horizontal transformation. Now, what kind of change is it? It's this negative, which is representing multiplication by negative 1. Whenever you have multiplication by negative 1, that is indicative of a reflection. So, between those two questions, we're able to identify that for this problem, what we're dealing with is a horizontal reflection. In other words, if we want to get the graph of p of x, which is equal to f of negative x, we just have to take the graph that has been provided for us and spin it around the y-axis. Now we know that when we have that kind of a transformation, a horizontal reflection, a spinning around the y-axis, what used to be on the right is now on the left, and what used to be on the left is now on the right. In other words, the x-coordinates change signs, but the y-coordinates stay the same. So the x-coordinates are going to change signs, and the y-coordinates will stay the same. Since the y's are going to stay the same, let's go ahead and copy those now. So these y's are identical, but the x's change sign. So negative 2 pi becomes positive 2 pi. Negative pi becomes positive pi. 0 stays as 0. Pi becomes negative pi, and 2 pi becomes negative 2 pi. Now we can plot our new points. So 2 pi 0, that's here. Pi negative 6 is down here. 0, 0 is here. Negative pi, comma 6 is here. And negative 2 pi, comma 0 is here. Now we have to connect the dots in a way that accurately reflects what the black curve would look like if it was spun around the y-axis. Let me see if I can illustrate this with my body. This isn't going to be the easiest thing in the world to do, but I'm sure going to try. So I'm going to shape my body like the graph that was given to us. This is f of x. If I take this and I spin it around the y-axis, what I'm going to have at the end is this shape right here. And so with that in mind, if you take this black curve and spin it around, what you should get is something that is shaped approximately like this. And that is the dots that we see. So if we can connect these dots together to form that shape, that should represent our final answer for this problem. And so with this in mind, we have now finished this problem, although I think I could do a slightly better job with this part of the graph here. Okay, so the blue graph is showing us our final answer for this problem. The black graph is f of x, the graph that was provided for us at the beginning. So black is f of x, Blue is f of negative x, also referred to as p of x.